Hello and welcome to this third installment of the Shop Made Tools and Upgrades video series. So in this video I'm going to talk about my 4x6 metal cutting bandsaw. Now these are quite common. Probably most people that tinker around in their garages doing machining and fabrication, have one of these metal cutting 4x6 bandsaws. They are really cheap and they are a really good tool. I have done some modifications to the bandsaw itself, but included in this video I'm going to talk about the base that you can see there that it's sitting on. And I haven't done all the modifications that I want to yet, so it's still work in progress, but you can see that this bandsaw actually sits on kind of like a pedestal, and underneath that there is a tray, and that tray is designed for flood coolant, which I do want to add to this machine at some point. Let me get the camera a little bit closer in and let's have a look at how this base works. So you were just looking at the other side of the bandsaw, and that's all, as you saw, was closed in with some panels. However, this side of the bandsaw, it's opened down the bottom here, and that is mainly just for storage that goes in there. It's where the drain for the coolant would come in here as well. And I plan to use a window washer bottle from a car to do the pumping of the coolant up to the blade. But as I said, that's not been done yet, so we'll do that, in a future project. But at the moment, we've just got storage down the bottom there. There's a couple of jaw plates there that you can see. I'll talk about that a little bit later. And in the container, there's just the bits for the drain for the coolant. So this base frame is pretty heavy as well. With the saw on here, two people would struggle to lift it. It's made of 1 inch by 2 inch rectangle section steel, which is 25 millimeters by 50 millimeters. That's probably about 2.5 millimeters thick, and the legs are made from 40 by 40 square, which is around about 1.5 inches by 1.5 inches. So it's a solid base. There's a 5mm plate on top, so that adds a lot more weight as well. So I need to move this around the shop from time to time because when I get deliveries of lengths of steel, they come in 6 metre, 8 metre, 9 metre lengths. So, trying to get them into the garage here and cut them in here is a bit of a mission. So I need to move the saw closer to the door so that I can cut the lengths of steel for storage. So as you can see down the bottom, you can see some blue wheels there. So this is actually on wheels, and that's what this silver mechanism is here. So I'll just show you how that works. There's a hinge down the bottom here and another one down over here, and there's another subframe with the wheels on it. And how that works is at this point it has been lowered, so it's actually sitting on the wheels, and I can move this just with one hand. It's really easy to move with the wheels down. Now once I get it into position, all I need to do is press on the bar here, and there's a little tab that sticks out on the side, and I push that in that way, and then I release the bar and it comes up. The wheels come up off the ground, and the base frame then sit on the feet on the ground there. So basically your foot goes in here, you push it to the side, and it comes up like that. And that's now solid there, and that won't move at all. Now I haven't taken any videos of building that mechanism because that was before I actually started making these YouTube videos. I have got some photos of it though, so I might put some of those up and describe that a little bit later. When you want to move it, you just push this down, and that lever is spring loaded, so that comes out automatically and locks it in place. And then once again, you can just wheel that around very easily. I did do a little bit of research into this, and I did find another YouTuber who made this type of design, and he made it for, I think it was a workbench. And I'll put his link in the description below because that might be useful information if someone's looking at this type of thing. Not necessarily for a bandsaw stand, but you know, for a small table or you know, anything else that you want to move around. So let's have a look at some of the modifications I've done to the saw itself. So the first thing you'll see here, some jaws. They're different to the original jaws. They're a lot bigger compared, and it gives me more length out the end here, closer to the work to clamp things, and some more length out the back here. And the reason why I need more length out the back, particularly on the front jaw, see it comes out, boy, that must be you know, coming up almost 3 inches further out the back here. And the reason why is because with the original jaws, they were sort of, I guess, in there like that, and that's fine when you're clamping to cut stuff at 45 degrees, but once you start twisting this around like that onto 45, then the jaw, you know, you're only getting this much clamping force here, and you're cutting way at the end here, so you've got a whole lot of metal that's unsupported here. And yeah, sure, you can put clamps in here, and you know, got to make sure that the arm doesn't come down and interfere with them and things like that. So there are ways to get around it, but I just found it better to make some larger jaws and just leave them on all the time. So this is another modification that I had to do at the back here with this hinge bar, and I had 2 issues here. I've actually done a video, so you can go and have a look at the video to get more information. But I think the 2 issues were, one, this end here was worn out, and there was a lot of play in there, which was making this arm, when it's down in the horizontal position, you know, when you're doing, it's sort of moving like this with a whole lot of play in there. And the second issue, this bar or hinge was not square to the table coming this way, and it was pointed more like that. That's exaggerating, but what it meant was when the arm came down, instead of coming straight down the table like this, it was coming, you know, out on an angle like this. So your blade wasn't actually running in the channel where it's supposed to be. So to remedy that, I made up a bush for this hole, and I actually filed the hole out, and I offset the hole when I was filing it to bring it more forward on this side here. That made a huge improvement than what it was. It still is not absolutely straight, although in saying that, as long as your blade is square to your fence, you should have no issues. So yeah, it is a big improvement, and in fact the you know, there's no play in here at all now, so that makes it a lot better and a lot more accurate cuts as well. So this was another modification. The top idler wheel here had a massive amount of play in the center, and it was all wobbly. In fact, it got to a point where the blade kept slipping off it. It was so out of alignment. When I took it all off to investigate, it was just a center shaft, and there was a you know, a bush inside the wheel, and that just got worn out, I guess, over the years, and you know, all the use that the saw had been through. So the option was to, you know, bore it out and put another bush in there, and I was sort of thinking of more of a long-term fix. So what I did is I bought a needle roller cage, and you know, that's a little bit different to your ball bearings. They're the long, skinny, round needle roller bearings, and I put that in there, and I tell you what, that has made this absolutely solid now. You know, with the blade off, I can just spin it round and it spins for ages. So it's, a lot less friction. And, there's no wobble if I'm pulling it back and forth down here. There's just no wobble in there at all. So that is a really, really good upgrade, and it will probably last a long time. And as you can see, I've just put a whole lot of grease in there as it needs to be lubricated. So the next thing I had to do with the saw was replace these bearings here for the blade. And that wasn't a very hard job. I took all this off and put it in the vise. Take the circlips off and you can pull the bearing off. And the bearing that's in here, you just punch this center rod through and that bearing in the back there will come out. So it's pretty easy to do. Now this part, there's a few adjustments for this. So depending on what saw you have, one of these or two of these shafts that the bearing sits on are adjustable, and they're on a sort of a cam. So when you put a spanner in here and you loosen the nut off the back, and then you can turn this and it will push the bearing more onto the blade, or it'll pull it away from the blade. So I've seen on some videos that both of these have the cam on them, and on this particular saw only one of them have the cam on it. So so that's adjustment there, and you don't really want this too tight on your blade. And there's a couple of good videos. So there's Rob from the Xanadu site, and he shows some videos, or he's got a few videos on the 4x6 bandsaw and how to make it cut straight. And there's also Winky's workshop as well, and he's got a bunch of videos as well to that talks about all this bit and replacing bearings and aligning everything. But anyway, I'll put the links down in the description for those. So if you want more information about the ins and outs of the blade guides here and the bearings and how to adjust them and set them all up, you can certainly look at those videos. So the last modification was the clamping mechanism here. And firstly, I've extended the handle out, because the handle used to be about where this bolt is here, and it was just hard to get under there, particularly with the arm down. So it was extended out past here, and that works absolutely perfect. I did some more modifications underneath, because I guess it depends on the quality of saw you buy and how much you pay. But for this particular one, it just went through a bush in the front here, and then it went into the sort of half nut down where the clamp is, and it sort of bounced around and floated around all over the place in there. So I actually put a bearing way down the end to keep everything in line, and it works absolutely perfect. And you can spin this very, very easily. Anyway, I haven't got any video on that, but I'll certainly show some photos of that work that I was doing to modify that. So we'll just jump back to a couple of the photos of the build of this bandsaw table. This is a good photo that shows the subframe for how the wheels work. So as I mentioned before, there's some hinges there. Those hinges are bolted to the main frame, but just on the inside of the main frame, you've got these bars, one down each side, and the wheels are connected to those bars. So effectively, the bars hinge and the wheels will come up, or if the bars are down flat, like how they are now, the wheels will be down. And I've got it up on blocks, and that's why they can just sit down there level. And if you look on the far left-hand side, this is how the mechanism works. The long bar is welded to this closest side here. And it's a long bar because it allows me to push it down from the other side. And then if you look just underneath it, about halfway along, there's another little bar that goes to the other side where the wheels are connected. And how it works is there's just right in the middle there, or at the end of the short bar, there's actually some ball bearings that are bolted there, and there'll be a spring that pulls all this mechanism up, And when you push that lever down from the other side, it pushes these wheels on the ground and it lifts the whole table up. So it's kind of a basic way of getting a table off the ground, I suppose. But it's an ingenious idea. And all you need then is the little latch, which you saw in earlier on, to hold it down. So this next image is of setting up the drip tray and the pedestals. And I sort of chose this image because it's got these two massive double-ended G clamps that I made. And I'll do a video on all the clamps that I've got maybe a little bit later on, but these were actually made out of, I think it was 12mm steel. It was actually part of a dentist chair. It, had a whole lot of holes in it. And I was able to find a couple of pieces that didn't have too many holes in, and I was able to make these G clamps or C clamps out of. But these are a little bit different because they actually have screws at both ends. So for these situations where I had to get under the table because there's a ledge there, I can actually screw the other end, the end closest to the ground there, and I can screw that in up to the bottom of the table plate there, and then the top screw will go down and hold that tray on. And I know you can use bits of wood and that to space it all out, but in some situations you need 4 hands to hold everything while you tighten things up. But these are great clamps, and to be honest, I haven't actually seen any double-ended clamps being manufactured, so maybe that's a good idea. So now we're getting into assembly here. Everything's painted, and I've got my probably a 4-year-old worker there helping me out, putting those wheels on the subframe. And then that was basically the table all complete, and it was just waiting for the drip tray to be galvanized and waiting for that to come back so that that could be put on and the saw could be put on. And those pedestals that actually come up and hold the saw, I mean, they're all sealed with sealer. So, once I do get the flood coolant system running on it, it should be okay, and there shouldn't be any issues with things rusting through or leaking out or anything like that. So I mentioned earlier that I extended the handle that does the clamping, and I thought I had some pictures, photos of what I did here, but I just can't find them. So I've just gone out and taken a couple of photos. They're not the best photos, but at least you sort of get an idea of what I've done. So the shaft that came out of here, it only came out like an inch from the end, and the original handle wouldn't clamp onto it properly, and it was all sort of flogged out and rounded. And the shaft where it goes through the housing here, the housing didn't have a bush in it. It was just flopping around in there as well, so it was worn out. And also, underneath, the lead screw just goes through to the half nut, and then there's nothing at the end, so it sort of flops. If you've got a bit of play here where the shaft goes through the housing, then, you're going to have slop and wobbliness going on further down the track there. So what I did, first thing I did is I extended out the lead screw shaft so that it was a lot longer. And I welded a larger diameter bit of shaft, as what you can see there in the picture, to it. So that allowed me to bore out the hole in the front there to a bigger size and make it fit nice and neat without, any play or anything in there. The second thing I did is I cross-drilled that shaft and this handle, and I put a bolt through there because it had kind of like a little grub screw before, and if it comes loose, because you're putting a lot of pressure on clamping stuff in the jaws, if that little grub screw comes loose, then it sort of starts rounding out the shaft, and I think that was the issue with how it was designed before. So with this cross hole with the bolt and nut through there, I mean, that's never going to come loose. And just on the other side of the housing, the original way it was set up, there was no thrust washer in there or anything like that. So when you tighten things up, the lead screw is pushing back on the housing. There are no washers or thrust washers or anything, so it was kind of chewing it out. So I actually made up some brass washers that were put in there just to make that a little bit better, and hopefully it doesn't wear out the housing. This is the shot of underneath, well, what I could do. And this is the end of the lead screw where it used to just sort of flop around. Now it actually goes into this round thing that has a bearing in it, so it's a bearing housing, and that's bolted with those two bolts that go up, and that lead screw just spins round straight now. There's no wobbliness or anything like that. And if I did get a little bit of play up at the other end where the handle is, it's not going to get much worse having this support at the end of the lead screw here. So it's quite a good design, and that would just last for ages now. Anyway, that's probably about it for the bandsaw and the table that I built for it. Look, if you've got any questions or comments, just leave them down in the comment section. And thank you for coming along and watching this video.